Hello everyone, welcome to my YouTube channel Zenith GATE Mechanical. Continuation with the concept and question series.
Support reaction. Support reaction. So why it is important? Because for solving the problem of beams and all, there will be support at the end point or some midpoint. So you have to apply the reaction which is offered by the support. So for that, you have to understood what are the different kind of supports and what are the reaction which will be offered by these supports on the particular body. Okay. So what is support? First of all, support is nothing but it prevent the translation of body in given direction by exerting a force on the body in opposite direction. It also prevent the rotation of body in a given direction by exerting movement in opposite direction. That means it will prevent the translation of a body as well as the prevent the rotation of body by applying some kind of forces and the movement, which is nothing but the resisting force and the resisting moment. Okay, so let's try to understood first of all, what are the different kind of supports. Now the support. So the first type is roller support. So let us suppose there is a beam which is supported with a roller. So it can also be represented in this manner. Okay, so there is a roller support. So the roller support will resist the motion in the vertical direction. That means only one reaction will come into the picture in case of roller support. The total number of motion which will be restricted by support, then it will give the reaction. So for free body diagram, what you will do? This is your beam. There will be only one reaction which is vertical. Why only in vertical? Because only one motion is restricted. It cannot move in the vertical direction, but it can translate and it can rotate also. So only one motion is restricted. That's why one reaction. Second is hinge support. Hinge support. So this is a beam which is hinged at this point. So how many motion can be registered? So two motion are registered. The first one is in the horizontal direction and vertical direction. So two motion are restricted means two reactions will come into the picture, which is nothing but vertical reaction RAV. This is A I am just considering. So one vertical reaction and one is the horizontal reaction. Okay, one is the horizontal reaction. Now moves to the next one, which is nothing but the fixed support. And this is also called as a fixed support. And this is also now comes to the third one, which is nothing but fixed support. It is also called as a built-in support. Built-in support. So in case of fixed support, how many reaction will come into the picture? The three reaction will come because three motion are restricted. So let us suppose this is the beam and there is a load which is acting at this end. And this is the point A, this is B. So how many number of reaction will come? The first one is this fixed support will resist the motion in the vertical direction, that means one vertical reaction, RA vertical, and there is a RA horizontal, because horizontal motion is also restricted, and the moment is also restricted. So three motions are restricted, that means three reaction will come. Okay. So the support is nothing but equal to the number of motion restricted. Okay. Now, based on the free body diagram, one question was asked in the GATE exam, which is nothing but this one. Force F, which is acting on a bent bar. So this is the bent bar, which is clamped at one end. Okay, so there will be a fixed joint as shown in the figure. So you have to identify out of these four options, which one will be the correct free body diagram. So you know the fixed support will give the three reaction. One is the horizontal reaction, vertical reaction, as well as the movement. Okay. Now there are the only two options, option A and option B, where are the three reactions. Okay, these two are eliminated because only here is the vertical reaction, there is movement, there is no horizontal reaction. Similarly, there is no movement. Now, from option A and option B, which one will be the correct? If you have a good understanding of free body diagram, then you can easily identify. What is free body diagram? Isolate the body from the all type of contact. That means, first of all, you will isolate, then you will apply the reaction. Now, if you see in the option B, there will be a hedged portion. That means support is also the contact is also there, and they have given the reactions also. So this option will be wrong. So the correct option is option A. First of all, you will isolate this body from all contact, then you will apply the reactions. Okay, so the correct answer for this question is, so this is the bent bar at the end where the force is acting F at an angle of 60°, and there is a horizontal reaction Rx, there will be one vertical reaction Ry, and there will be one moment, which is nothing but M. Okay, so the option A is the correct answer. So answer for this question is option A. Okay. Now, move to the next question. This question was asked in the GATE 2014. A letter AB of length is 5 meter and weight W, that means this W weight is given as 600 Newton, is resting against a wall, assuming frictionless contact at the floor and the wall. That means there is no friction which is acting on this particular surface, which is nothing but the wall and the floor. Okay. Now, you have to calculate the magnitude of force P, which is required to maintain the equilibrium of ladder. Okay, so you have to calculate this P force so that the ladder will be in the equilibrium. Because you know that this ladder has a tendency to move in this direction. That's why we are applying some P force to maintain the equilibrium. Okay, but for solving this problem, you have to, first of all, you have to draw the free body diagram. So how you will solve this problem? Just remove all type of contact and apply the forces. So there will be one reaction. Let us suppose this is the RB. This is the P force which is acting, and the W weight of the body will be downward. One more reaction will act, RA. And it is given that there is no friction acting on the both the surfaces. That means the friction value will be 0. If the friction is given, then you have to consider. Okay. Now, so this is the free body diagram of this ladder. Now what you will do? For equilibrium, you know the equation, summation of force in x direction 0, summation of force in y direction 0, and take the moment about any point will be 0. So I'm going to use those equation. So for equilibrium, summation of force is equal to 0 and the summation of moment is equal to 0. Okay. So if I will take summation of force in y direction 0, so can I write RB is equal to W, which is nothing but 600 Newton, because the weight of this ladder is given at 600. Suppose if I will apply summation of force in x direction 0, can I write RA value is equal to P? Okay. So RB value, which is you have calculated 600, but RA and P both are unknown. Then one more equation is left. What is that equation? Take the moment about any point will be 0. So what I will do, I will take the moment about this point, and about this point, which force is creating a moment? This W and this RA. Okay, so let me take this figure.
And you can use the third equation, which is nothing but the summation of moment about any point is equal to 0. So I'm taking the moment about B is equal to 0. So what are the forces which will create the moment? One is W and another will be RA because I'm taking the moment about B point. So RA into 3, which is in clockwise direction, minus W into 2, which is in the anti-clockwise, is equal to 0. So from here, you can calculate the RA value because the weight of ladder, which is already given 600 Newton. So this is 600 into 2 divided by 3. So RA value is 400 Newton. So once you know the RA value, now you can calculate the value of P by using the first equation. This RA is equal to P. So RA is equal to P, which is nothing but equal to 400 Newton. So this is the P value which you have to apply, which is nothing but 400 Newton, so that the ladder should be in the equilibrium. I hope this series truly help you in your exam preparation. So don't forget to like, share and subscribe. Thank you so much.